All right, so in this video, we're going to be starting our next unit. We're going to be talking about solving and graphing quadratics. Now, in this first section, we're going to be doing that by factoring. In other words, when we get ready to graph, we're going to be using what's called factored form. Before we can do that, though, we need to talk about solving. And in order to solve, we need to talk about zero product property. It's a very simple property, but very useful in a lot of the things that we do for this section. So what the zero product property says is that if you have A multiplied by B equals 0, then either A has to be 0 or B has to be 0. In other words, let's think about A and B as numbers. If you're multiplying two numbers together and the product or the answer is 0, then it must be the case that at least one of those numbers is 0. Now they can both be 0, or it could just be that one is 0 or the other is 0, but at least one of those numbers has to be equal to 0. Now, what that also means then is if A and B are expressions, then one of those expressions has to equal 0, which means that we're going to set each of our factors equal to 0 and then solve. So let's do some practice with that. So we're going to solve each of the following using the zero product property. So notice that rather than having numbers, we've got expressions, and that's okay. That either means that x minus 3 has to equal 0, or that 3x plus 4 has to equal 0. And then what we'll do is we'll solve for each of those. So for the first one, just add over the 3. So x equals 3 would work for our equation. For the other, we'll first subtract the 4, then divide by 3 on each side. In other words, x equals negative 4/3 would also be a solution to our equation. All right, let's do the same thing on number 2. So number 2, the only thing that's just a little bit different is that notice our first part is just x by itself. That still gets set equal to 0. The second part is 5x minus 3. That gets set equal to 0 as well. Now the first one, for x equals 0, obviously you don't need to do anything there. You're already done. For the second one, we'll just add over the 3 and then divide by the 5. So x equals 3/5 would be a solution to that equation. Let's do one more just to make sure that all this makes sense. For the next one, there are 3 things being multiplied. Obviously, 2 does not equal 0, so that's not going to be a solution. We'll then set 3x minus 8 equal to 0 and solve that in just a moment. And the last one would be setting negative x plus 7 equal to 0, and again, we'll solve that now. Okay, so for the first one, 3x minus 8 equals 0. We'll first add over the 8, then divide by the 3. So x is equal to 8/3 would be a solution to this equation. For the next one, we'll subtract the 7, and then we'll switch the signs on each side. So negative x becomes positive x, negative 7 becomes positive 7, so we get x equals 7. So zero product property, you can probably see, is pretty easy to use, pretty easy to work with. Unfortunately, not every problem is going to be set up so nicely. We're going to have to find those 2 parentheses in order to solve. So let's do a little bit of practice with that. So let's do some practice with factoring. Let's start with number 4. And on number 4, just a reminder, always make sure you're checking for a greatest common factor first. Between 3x squared and 9x, both of those have a common factor of 3x that we are going to factor out. So 3x squared divided by 3x is just x. 9x divided by 3x is 3. And now we've got our 2 factors. So in order to solve, we'll use zero product property, set both of those equal to 0, and then solve each of them. So the first one divided by 3, 0 divided by 3 is just 0. For the other, subtract 3 from both sides, so x would be equal to negative 3. Okay. Number 5 is also a special case. Let's first go ahead and take out our greatest common factors. So between 298, those are both divisible by 2. When we take out the 2, we're left with 100x squared minus 49 in the parentheses. And then this is a special type of factoring. Notice that our 2 terms are both perfect squares and that there's subtraction in the middle. Remember that this is what is called a difference of squares, and this is a special type of factoring. The square root of 100 is 10, the square root of x squared is x, and the square root of 49 is 7. So then our 2 factors for what's in parentheses would be 10x plus 7 and 10x minus 7. Okay, so now that we've got everything factored, we'll go ahead and use zero product property to solve from there. So obviously 2 does not equal 0, but we can set 10x plus 7 equal to 0 and 10x minus 7 equal to 0 as well. So for the first equation, we'll go ahead and subtract the 7 and then divide by 10. So x is equal to negative 7/10. For the next, we'll add over the 7, divide by 10. So then x would be equal to 7/10. So notice that when you have difference of squares, your answers are going to be opposites. Negative 7/10 and 7/10 are additive opposites. They're additive inverses for each other. Okay, let's do some more examples. Now we'll get into kind of more of the basic factoring that we are used to. So on number 6, we've got x squared plus 5x plus 4. So remember, we're looking for numbers that multiply to be 4, that also add to be 5. Obviously for 4, pretty short list, 1 and 4 or 2 and 2. And to add to be 5, we're going to want to use 1 and 4. In other words, if we take x plus 1 multiplied by x plus 4, that should be the same as x squared plus 5x plus 4. Now that we've got it rewritten using our parentheses and notice that it's equal to 0, now we go straight into zero product properties. So x plus 1 equals 0 and x plus 4 equals 0. So for our first solution, we'll get that x is equal to negative 1. For the next, we'll subtract the 4, so x equals negative 4. All right, let's do some more examples. Let's take a look at number 7. So number 7, we've got 3x squared minus 21x plus 30 is equal to 0. First thing that we should probably do is notice that there's a greatest common factor that we can remove from our equation. So that greatest common factor that we can divide out is 3. When we do that, 3x squared just becomes x squared, negative 21x becomes negative 7x, and 30 becomes 10. Once we've done that, we're now looking for numbers that multiply to be 10 that also add to be negative 7. So for 10, again, pretty short list. We've got 1 and 10 or 2 and 5. Now, obviously 2 and 5 would add to be positive 7. If we change those both to be negative, negative 2 and negative 5, those add to be negative 7, and they still multiply to be positive 10. So there's going to be our two factors that we'll use. And since they're negative, we'll write them as minus. So x minus 2 and x minus 5. Don't forget the 3 that was in front of your parentheses. Now, why I say don't forget it, it really won't work for a solution, so it really doesn't matter too much. But the other two will matter, so x minus 2 equals 0 and x minus 5 equals 0. And then from there, we'll solve. So for the first one, we'll get x equals 2. And for the second, we'll get x equals 5. Now, this would be a good time to point out a relationship that could help you skip a step. Notice that for the most part, your factors are the opposite, or your answers are the opposite of the factors. So if you have x minus 2, then x equals 2 is your solution. X minus 5, then positive 5 is your solution. So if you wanted to start trying to skip this step for the simple equations, that would probably be okay. We are about to start looking at some more difficult equations, starting with number 9, where that won't work. So while you might have noticed that, just kind of be careful with it because it will not work all the time. All right. So for number 8, this is kind of the last of our easy ones. We're going to look for numbers that multiply to be 12 that also add to be 8. Well, numbers that multiply to be 12, we've got a little bit longer list. 1 and 12, 2 and 6, 3 and 4. And the combination that will add to be 8 is 2 and 6. So then our two factors are x plus 2 and x plus 6 equals 0. Now we'll set them equal to 0 to solve. So our two solutions should be x equals negative 2 and x equals negative 6. Okay, so on number 9, we get to some slightly more difficult problems. But really they aren't too bad. I'm going to show you a method that's pretty nice, pretty easy to work with. Remember that there were kind of 3 different ways I showed you how to do this if you watched the factoring review video. So if you want to see one of the other ways, feel free to watch that video. I'm going to kind of show you the way I like best, and we'll use that method to work through these. Okay, so the first thing to point out on number 9 is that obviously you can't divide everything by 3. So there is no way to get rid of that number in front of x squared. When that's the case, we're going to have to solve this just a little bit differently. And so what we'll end up doing is we're going to take a multiplied by c. That would be 3 multiplied by 8, which is 24. So I'm going to set up this diamond, which is going to help us just kind of put everything together and organize it. So the 24 is going to go on top. The positive 10 is going to go on the bottom. And what we're looking for is numbers that multiply to be 24 that also add to be 10. Now, I'm not going to list all those out. You can probably find a combination that works pretty quickly. Hopefully you can see that 4 and 6 are going to work to multiply to be 24 and also add to be 10. Now here's where things get a little bit tricky. We're going to now take that number that was in front of x squared and we're going to put that above each of those two numbers that we just found. In other words, you're not writing x plus 4 and x plus 6 as your two factors. We've actually got one more step to go. And here's where that is. For each side, you're going to think of it almost like a fraction and see if there's anything you can simplify. Now, for 3 and 4, obviously there's no common factors. But for 3 and 6, there are. Both of those are divisible by 3. And if we take 3 and divide by 3, that's 1. 6 and divide by 3, that's 2. So our two factors that we're going to set up for our two parentheses, we're going to use those numbers on either side to fill in our two factors. The first number goes in front of x, so for the 3 and the 4, you'd have the 3x, and then the 4 is positive, so 3x plus 4. For the right side, we're going to have 1 in front of x and a positive 2 after, so 1x plus 2. Now, if you want to check to make sure we did that correctly, multiply out those two parentheses, make sure you distribute everything, and it should be the same as what we started with, the 3x squared plus 10x plus 8. Now, at this point, we are good to go ahead and solve by zero product property, so set each of those equal to 0, and then we'll go ahead and solve. Now, this is why I said be careful. Don't just take the opposite all of the time of the number in parentheses, especially for our first equation. It's not x equals negative 4, but 3x equals negative 4, because then there's one other step. We have to divide by 3 on each side, so one of our solutions is x equals negative 4/3. For the other equation, yeah, a little bit more simple. You can just take the opposite. So subtract 2 from each side, and you'll get x equals negative 2. Okay, obviously these problems a little bit more difficult. Let's do a couple more examples of this just to make sure that everything makes sense. So on number 10, same idea. We've got a number in front of x squared that's not going to be divisible. It's not a greatest common factor. So we're going to start this problem by taking that number multiplied by the last number. So a multiplied by c, 3 multiplied by 4 is 12. And then we'll set our middle number at the bottom. So we're looking for numbers that multiply to be 12, that add to be negative 8. And again, I'm not going to list out all of those numbers. To multiply to be 12, you might think 6 and 2. To get a negative 8, those will both have to be negative, so negative 6 and negative 2. Now, once again, we're going to take our first term, which was the 3, and set that above each of those two numbers. And once again, we're going to try to simplify if possible. On the left side, the 3 and the 6 are both divisible by 3. 3 divided by 3 is 1. Negative 6 divided by 3 is negative 2. For the right side, nothing we can do to simplify there. So then setting up our two factors, for the left side, the 1 and negative 2 will become 1x minus 2. For the right side, the 3 and negative 2 will become 3x minus 2. And now we should be ready to set both of those factors equal to 0 and then solve from there. So for the first one, add over the 2 and we'll get x equals 2. For the second, also add over the 2, we'll get 3x equals 2. And then to get x by itself, divide each side by 3. So x is equal to 2/3. Okay, lastly for number 11, let's do it one last time. So once again, notice that the 2 in front of x squared is not a greatest common factor. So we're going to take that and multiply by the last number. 2 multiplied by negative 3 is negative 6. The negative 5 that's in the middle we'll put on the bottom. And we're looking for numbers that multiply to be negative 6, that add to be negative 5. Now here's where you have to be careful. It's sometimes tempting to want to use numbers like -2 and -3 because obviously they add to be -5. However, -2 multiplied by -3 does not equal -6. So you do have to be careful, especially when the numbers are 6 and 5. It seems like those are numbers where a lot of people will make some easy mistakes. The numbers we should be using are -6 and +1. -6 multiplied by 1 is -6, and if you add them together, they do equal -5. Next, let's take our number that was in front of x squared. So let's take the 2, put it above each of those, and now we'll go ahead and simplify. Only the left side can be simplified. 2 divided by 2 is 1. -6 divided by 2 is -3. And now we should be able to go ahead and write out our factors. So the first one using the left side would be 1x minus 3. The second, using the right side, should be 2x plus 1. Now, we'll use zero product property to set them both equal to 0. And then we'll go ahead and solve. So for the first one, x minus 3 equals 0 means that x must equal 3. For the second, we'll subtract over the 1, then divide each side by 2. So x must be equal to -1/2. Okay, so this is kind of the halfway point of the notes. So that was all about how to factor and to solve by factoring. That's going to be an important thing to know how to do for this next half of the notes where we are graphing in factored form. So in order to graph in factored form, here are the steps that we are going to use. Step number 1, factor if needed, and then use our factors to find the x-intercepts. In other words, step 1 is to solve the equation. Step number 2 then is we're going to find our axis of symmetry, which is going to be the midpoint or the middle of our two x-intercepts. Step number 3, we're then going to use our axis of symmetry to find the y value of the vertex. So where on that axis of symmetry does our vertex lie? Step 4, we're going to find our y-intercept and reflect that over our axis of symmetry. And step 5, we're going to connect the points to create our graph. Okay, so let's just do a little bit of practice with that. I've got a simple equation over here that's already factored. So we've got f of x equals -2, parentheses x minus 2, parentheses x plus 3. So step number 1, already done factoring. But the other half is to find each of the x-intercepts. What that means is that each of these equal to 0 and solve. So x would be equal to 2 and x would be equal to -3. So then there would be our two x-intercepts. One would be at 2, 0. The other would be at -3, 0. Step number 2 is we're going to find our axis of symmetry, which is the middle of our two x-intercepts. So the easy way to find that is let's go ahead and find the middle. We'll find the average of those two numbers. So 2 plus -3 over 2 is -1/2. So our axis of symmetry is x equals -1/2. Remember, axis of symmetry is always a vertical line. That's why I'm writing x equals. Step number 3, we're going to use our axis of symmetry to find the y value. In other words, take -1/2 and plug it into our equation. So -1/2 minus 2 multiplied by -1/2 plus 3. So then that becomes -2.5 as a decimal multiplied by +2.5. And now we just need to simplify that just a little bit further. So if we take -2 multiplied by -2.5 multiplied by +2.5, that gives us 12.5 as our y value. In other words, our vertex would be the point -1/2, 12.5. And then from there, we would find our y-intercept. Remember, to find the y-intercept, you just put 0 in for x. So let me do that real quick. If we put 0 in for x, we'll get 0 minus 2 and 0 plus 3. So that becomes -2 multiplied by -2 multiplied by 3, which ends up being 12. So our y-intercept is going to be 0, 12. Let me go ahead and label these. So this was our y-intercept. This was where we found our vertex. This is where we found our axis of symmetry. This is where we found our x-intercepts. And at this point, we would have everything that we need in order to graph. Okay, so let's actually do that with some examples. So for each of the following functions, we're going to find all of this information and then draw a sketch of the function using at least 5 points. Okay, so let's actually start with drawing a sketch using those steps that we just talked about. So step number 1 was factor and use the factors to help us solve for the x-intercept. Now, on number 12, notice that 3x squared plus 9x is actually the same as number 4. We've already factored it, so we know what the factors are. We also know what the x-intercepts are. So let's just go ahead and copy those down. So our factorization would be 3x multiplied by x plus 3. So our x-intercepts that we've already found would be 0, 0, and negative 3, 0. Okay, let's go ahead and graph those. So we're going to have a point at 0, 0, another point at negative 3, 0. Now, for axis of symmetry, we can really just kind of look for where would be the halfway point. So the halfway point would be right here in between those values, which is kind of halfway in between two numbers. It looks like it's halfway between negative 1 and negative 2. And so if that's the case, then our axis of symmetry would have to be at negative 1.5. So axis of symmetry, x equals negative 1.5. Next, we're going to plug negative 1.5 into our equation to find our vertex. So let's go ahead and do that now. So we would have 3 multiplied by negative 1.5 multiplied by negative 1.5 plus 3. And you could have used the original equation instead if you would have liked to. It really doesn't matter which one you use. Let's go ahead and multiply those together. So that would be 3 multiplied by negative 1.5 multiplied by positive 1.5 tells us the y value is negative 6.75. So our vertex is negative 1.5, negative 6.75. So for vertex, we'll go ahead and copy that down, negative 1.5 and negative 6.75. And then we'll go ahead and graph that as well. So we'll go to negative 6.75. So 1, 2, 3, 4, 5, 6. So almost to negative 7 would be this point kind of right here. And now we really just have a couple more things to do. Our next step is to find our y-intercept. So for the y-intercept, now we put 0 in for x. So that would be 3 multiplied by 0 multiplied by 0 plus 3. And when we multiply all those together, those end up being 0. So our y-intercept is at an x value of 0 and y value of 0. In fact, that is the point right here that we've already got. And so when we reflect that, we've already got that point right here. So it turns out we actually have all of the points that we need. Now, it says to use at least 5 points. If one of your points ends up being both an x and a y-intercept at 0, 0, then I'll be okay with you just using 3 points to graph instead of 5. So this is kind of a special case where I'll be okay with that. So here would be our graph. We're going to connect those points very carefully. Let me try to get this to look good for us on both sides. There we go. Cool. So now let's go ahead and fill in the rest of this information. So the first question is whether this graph opens up or down, and pretty clearly this graph opens up. For max or min then, we're looking at our vertex, and pretty clearly our vertex is a minimum. Now, here's where I do want to talk about max or min value. We hadn't talked about this yet, but the max or min value is the y value of your vertex. So the y value of your vertex is negative 6.75. That is the minimum value for our function. For domain, that's just all real numbers. And then for range, we're looking at our y values. The lowest y value that we can get to is negative 6.75, and then everything above that. So our y values must be greater than or equal to negative 6.75. For number of real solutions, that just means the number of x-intercepts that we have. In this case, that was 2. Okay, let's do a couple more examples to make sure that this all makes sense. So number 13, we've got g of x equals x squared plus 5x plus 4. Once again, I've picked these out so that they always match one that we've already seen before. That is number 6 from before. So we already know our factored form is right here, and we already know our x-intercepts are right here. So really, we should be able to just copy those down. So again, the factored form of this is x plus 1 and x plus 4. Our two solutions are our x-intercepts. One solution was negative 1, so negative 1, 0. The other solution is negative 4, so negative 4 comma 0. Okay, so then let's go ahead and put those on our graph. So we've got a point at negative 1, 0, another point at negative 4, 0. Halfway in between those is also going to be halfway in between a couple of numbers. It looks like that's going to be at about negative 2.5. So that's going to be our axis of symmetry, is going to be at x equals negative 2.5. If you don't feel comfortable finding that visually, remember that is also something you can do by hand. If you take the average of those two numbers, negative 1 plus negative 4, and divide by 2, that becomes negative 5 divided by 2, which is negative 2.5. So axis of symmetry you can either find by actually using the numbers or just visualizing on the graph where the halfway point would be. Okay, so now let's go ahead and find the vertex next. So for vertex, we're going to use that x value that we just found and plug that into our equation. So that would be negative 2.5 plus 1 multiplied by negative 2.5 plus 4. So the y value for our vertex, let's go ahead and type that in. Negative 2.5 plus 1 and negative 2.5 plus 4 comes out to be negative 2.25 for the y value of our vertex. So our vertex is at negative 2.5 and negative 2.25. So again, on our graph, we'll go to negative 2.25 on our axis of symmetry, and that's going to be about right here. Next, let's go ahead and find our y-intercept. So for y-intercept, we're just putting in 0 for x this time. So 0 plus 1 multiplied by 0 plus 4. And that becomes 1 multiplied by 4, which is 4. So our y-intercept, x value is always 0. Y value this time is 4. So that would be 0 comma 4, which would be this point right here. Now, on the previous problem, we didn't have to do this because our y-intercept was an x-intercept. But this time, we're going to go ahead and reflect that y-intercept over our axis of symmetry. So when we reflect that, we're going to go over by the same amount from our axis of symmetry on the left side, which ends up being at the point negative 5 comma 4. Now we've got all 5 points that we need for our graph. We can go ahead and draw in our function between those points. Okay, so now that we've got our function, let's go ahead and fill out the rest of this information. So for which way it opens, this one also opens up. For max or a min, that means that this also has a minimum. Remember, the max or min value is the y value for our vertex, so negative 2.25 is going to be our minimum value. For domain, once again, this is all real numbers. And for range, that's going to be everything above, so y greater than or equal to the y value for our vertex, which is negative 2.25. Finally, for number of real solutions, there were 2 places where it crossed our x-axis, so then there would be 2 real solutions. All right, let's do one last problem to make sure it all makes sense, and we will be done with this section of the notes. So for the last one, we've got h of x equals 3x squared minus 8x plus 4, which just so happens to be number 10. So we already know our factored form, which is right here. And we already know our 2 solutions, which are right here. Okay, so let's go ahead and copy those down. X minus 2 and 3x minus 2 were our 2 factors. So our 2 solutions, which are our x-intercepts, would be at positive 2, so 2 comma 0, and at positive 2/3, so 2/3 comma 0. Okay, so putting those onto our graph, I'm going to zoom in just a little bit. Here would be 2, 0, and here would be 2/3, 0. Okay, now this is a problem where finding the axis of symmetry by looking at the graph, it's going to be pretty difficult to be accurate with. So let's go ahead and find the average of those 2 numbers for our axis of symmetry. So if we take 2 plus 2/3 and divide that by 2, we're going to get 1.3 repeating. I'm just going to write that as a decimal to make it a little bit easier to graph. So 1 1/3 would be another way to think about that. So our axis of symmetry, x equals 1.3 repeating on our graph. Let's go ahead and graph that now. So that would be about right here. And then we'll go ahead and draw in that axis of symmetry. between our two x-intercepts. Okay, so let's go ahead and find our vertex next. We'll figure out where on that axis of symmetry our vertex lies. So we'll put 1 1/3 into our equation for x. So 1 1/3 minus 2 multiplied by 3, 1 1/3 minus 2. So we'll go ahead and type that in now. And it looks like negative 1 1/3, negative 1.3 repeating, is going to be our y value for our vertex. So again, vertex is going to be at 1.3 repeating and negative 1.3 repeating. Okay, so putting that on our graph, again, zoom in a little bit here. So negative 1 1/3 would be about right here. Okay, last but not least, we're going to go ahead and find our y-intercept. So for y-intercept, again, put 0 in for x, so 0 minus 2 multiplied by 3 times 0 minus 2, and that ends up being at positive 4 when you put that into calculator. So y-intercept is going to be at 0, 4. So we'll go ahead and plot that now. Positive 4 would be right here. And then we'll go ahead and reflect that over our axis of symmetry. So we go over by 1 1/3, over by 1 1/3 more. It's going to end up being right around 2 2/3, 4. So then here would be our parabola through those points, looking something like this. Okay, so once again, this one opens up, has a minimum. For our min value, then, we'll look at the y value for our vertex, so negative 1.3 repeating. For domain, once again, we've got all real numbers there. And then for our range, we're looking at y values being at least equal to our minimum, which was negative 1.3 repeating. For number of real solutions, once again, it crossed twice, so that's going to be our number of real solutions. All right, guys, that is it for the notes for this section. In the next section, we'll be looking at another way to solve and graph, which is going to be solving by completing the square and graphing what's called vertex form. Until then, have a great rest of your day.